Now you can. Thank you. So when I say part over whole equals part over whole, so if you were to look at it, the angular size, which is really this angle right here, right? And if we go all the way around, would be 360 degrees. That's why angular size over 360 degrees, which is part over whole. The other size is the physical size. So where I'm talking about this blue right here. Well, the blue right there is taking up part of the circumference of the circle. So the whole would be the circumference, and the circumference of a circle is 2 pi times the distance, and the distance is your radius, because remember I said your eyes is the center of the circle, right? Because circumference is 2 pi r. So I don't want you to think of it as 2 pi d because I said distance. Distance meaning from here to here, which is your radius. Got it? Are we okay so far? So, if the angular diameter of the moon as seen from Earth is approximately 0.5 degrees, and the moon is approximately 380,000 kilometers from Earth, what is the real diameter of the moon? So how do I put this information in here? What do I know? Okay. So we know the distance, right? And that distance is what else do we know? Do we know the physical size or angular size? We know the angular size. And since I have a single fraction equaling a single fraction, this is where we can actually cross multiply. Meaning, this times this. Hey, I want an arrow. Actually, let's just say P. So that means P is going to equal to and tell me what you get there. Approximately what? Approximately Are we okay there? Yes? No questions? We're good. That makes sense. Are we going to be able to remember this? Because the angular size is the angle, right? So the hole would be 360 degrees. Since the actual size is going to take up the circumference, so the whole thing would be the circumference, which is 2 pi r, or the distance my eye is away from the object. So why is pitch important? Why is pitch or slope or grade important? Well, the problem is that in Florida, there's not much pitch, is there? Or grade, because we're in the same altitude. So when you guys look at your gutters, do you think there's a pitch to it? Or does it seem pretty flat? It's hard to see. There's actually a pitch to it. Do you know why it has to have a pitch to it? The water's just going to sit up there. And you know what rainwater is going to smell like when it just sits there? It's going to stink, right? Just like the water in the man-made ponds. They don't drain anywhere. So sometimes when you drive, I know I like on the corner of Oil Well and Immokalee, like when I'm driving past that school right there, it always smells like someone lay a fat one out. And it's just sitting there and simmering, and I'm just driving right through that stench, right? That's what it's, so we don't want water to just sit. The reason why we don't want water to sit is because why? Mosquitoes, right? Like they want to lay eggs in still water, right? So we have to have a pitch, we have to have a grade. So like up north when I was living in Pennsylvania, I bought a house and the yard wouldn't drain. So there was a storm drain in the yard, and it was a backyard that wasn't draining. So I had to like say, okay, so I need to at this here, and I'm going back. I have to have a grade, right? Because if it goes uphill, then it's no good, because the water ain't gonna drain, right? So I had to plan it so that it still went uphill enough, or I'm sorry, downhill enough that the water would drain, and that get into the yard and not have it sit anywhere, right? So I had a starting point to the end point. The cool part about drainage is that it doesn't need a lot, right? With drainage, it's like 1 inch in 10 feet. So a 10-foot length, you only got to have it move by 1 inch. So notice I said in. 1 inch in 10 feet, right? So the issue is that a lot of times they don't use labels with it. They use the same label for both. Okay? So they might say, hey, the pitch is 1 in 10. Oh, sorry. And that might be 1 foot in 10 feet, right? The pitch that I just mentioned was 1 inch in 10 feet. That's when I would actually have to label those numbers, okay? But if I say 1 in 10, that means that could be 1 feet in 10 feet or 1 meter in 10 meters. But that pitch is still exactly the same. But it's different from 1 inch to 10 feet. Make sense? Okay. Yeah. Yeah, it's still about 3,300. It's okay. Yeah. I thought you were going to get like 5,000 or something. Then I'd be like, whoa, what the heck happened? Right? So in terms of slope, that'll be 1 over 10. And what's 1 over 10 multiplied by 100? That's going to be 10%. So depending on what you're talking about, pitch, slope, or grade, those have different things, right? The pitch and slope is pretty much the same, right? So 1 divided by 10 is 0.10 times 100. You move the decimal place twice to the right. That's your percentage. So grade takes decimals and converts it to percentage. Okay. Suppose a road has 100% grade. What is the slope? What is the pitch? And what angle does it make with the horizontal? %100% grade. So what's the pitch? What's the slope? Think about grade. Grade means the change in the vertical distance divided by the change in the horizontal distance times 100. So what divided by what times 100 is going to give you 100? Wouldn't it be 1? 1 times 100 is 100, right? What kind of fraction is 1? It'd be 1 over 1, 2 over 2, 3 over 3, right? So the slope is going to be 1 over 1. The pitch is going to be 1 in. Oops. And what's the angle with a horizontal? If it's 1 and 1. Right? Think about this. If I went 2 and 2, in that angle right there, 45 degrees? Yes? We're okay? Okay. Which is steeper? A road that's 8% grade, or a road that has a pitch of 1 and 9? Is it easier to make grade a pitch or pitch a grade? Agreed. She's speaking in bat. I can hear her, but nobody else can. Yes, it's easier to convert pitch to grade. So how do I find pitch to grade? Oh, now everybody else can hear her. So you go 1 divide by 9, and then multiply by 100, right? That'd be your grade. And what is that going to be? No. 0.11 or 11.1%. Right? So compared to the 8%, guess which one is deeper? Does that make sense? Which is steeper? A roof pitched that is 2 and 12 or 3 and 15? I would do the same thing, absolutely. I would definitely do the same thing. So you're going to do 2 divided by 12. What's 2 divided by 12 times 100? And 3 divided by 15 times 100? 20. So which one is steeper? Pretty easy? So before those laser distance measures, right? So with a laser, I can like stand here and I can point it to that wall, and the laser would tell me what the distance from here to the wall is, because it feeds back to this, right? Before that, surveyors would have to do literally this. They'll actually have to do math. But surveyors, if they get government contracts, actually get paid really well, right? So they're using Pythagorean theorem. And the Pythagorean theorem says a squared plus b squared equals c squared. Okay? And so Pythagorean theorem is only done on a right triangle. It talks about the relationship of the sides of a right triangle. Okay? So A and B is called the legs. The C is called the hypotenuse, which is the longest side. And it's also the one that stands alone. So if you see a squared plus b squared equals c squared, well, c is so special, it can stand by itself. It's larger than a and b. Okay? Bless you. All right? And the side that's largest is going to be opposite of the largest angle. So if you look at any triangle, the side that's opposite of the largest angle is going to be your largest side. The side that is opposite of the smallest angle is going to be your smallest size. So if a surveyor was trying to find how wide a lake is or pond is, this is what he would have to do. He'll mark it perpendicular to it, go a certain distance, and then say, okay, what is the measure of this length from where I'm standing to the other edge? And then they'll use Pythagorean theorem to figure out what the width of the so-called lake is. So why don't you guys go ahead and tell me what the width of the lake is? What'd you get? 18.14? Let's see. So I'm guessing she did x squared plus 20 squared equals 27 squared. Then she said x squared plus 400 is equal to whatever 27 squared is. 729. So she said x squared is equal to 329. Then she took the square root of both sides. So she said x is equal to, what's the label on that? Miles. Awesome. Are we okay there? Not bad? All right, so similar triangles. A similar triangle just means that when two triangles are similar, all it means that is that three angles of both triangles are the same. And if the angles of the three triangles are the same, then their sides are in proportion with each other. Right? So I make sure I color code it. So A over D is the same as B over E. Now, guys, we have to keep it. This is not about fairness. This is about keeping an order. So if I said A over D, then I have to say that's equal to B over E. Does that make sense? I got to stay consistent. Not fair, consistent. Okay? It's the same thing with life. Everything you do, how you do anything is how you do everything. Right? So if you come late to class, chances are you go late to work. Right? Chances are you cheat on your workouts. Guess what? You probably cheat at home as well. You probably cheat on your diet. I know that just got serious. So when I'm working out in the gym and someone says, "Let me cheat," I know that's not a relationship that is never going to be with me. Because that means they're going to just cheat in the relationship as well. How you do anything is how you do everything. Okay? Now, when they tell you that two triangles are similar, they're probably going to say that just like this right here. Triangle ADE is similar, which is that squiggly line, triangle ABC. So that means A and A are similar, are equal. D and B are equal, and angle E and angle C are equal. Okay? So that is what you're going to see. All right? And I would strongly suggest that you actually mark those angles down. So you see the angle with a single hash versus 3 hashes versus 2 hashes. Make sense? So in this problem here, and I even color coordinated sides just so that I know which sides are corresponding, right? So if I had to find CA, CA is right here. The corresponding side with that is 15. I see 9 here, which is the blue side. The corresponding side must be 3. So I would write what proportion? So x is equal to, can I cross multiply? Yes. Why? Because it's a single fraction equaling a single fraction. That's the only time you can cross multiply. Okay? The reason why I'm bringing that up is because I know in my algebra class, anytime we have any kind of fractions with an equal sign, they're like, cross multiply. Well, no, we can't cross multiply all the time. It's only certain situations that we can cross multiply. It has to be a single fraction equaling to a single fraction. So if anybody needs to see the work, here it is. And there you go. Any other questions? Oh. And that's all she wrote. So, what kind of questions do you guys have for me?
Back to the pitch, slope, and grade one, the first question. How did you get the, on the third question, on the third one, how did you get the 20%, or, what angle does it make with horizontal, that, the first question, my bad.
Mm-hmm.
How did you get the 45? 45 degrees.
So, you agree with the 1 and 1? Okay. So, if I was to draw this in the 1 and 1, that'd be 1 and 1. Agreed? So, and you agree that this right here is a horizontal. So it's asking me, what angle does this make with that? Just unmute yourself and speak.
Doing it anyway, it was kind of like a warning thing that I was gonna talk. How would you find it with like a different, like pitch or slope? Would you just use like the Desmos thing to find the angle of those ones? If it was like 1 and 2 or something.
I'm trying to think if there is a way of doing it as an angle without using trig. Right? Because if it was a 1 and 2, is a lot harder to find. I can find that distance, but I can't find the angle without using trig.
Oh, okay. So I don't have to worry about that.
Correct.
Okay, cool.
Until I teach you trig, then you'll have to be careful with it.
Okay.
Okay? Which would be tangent of the angle. So it would be inverse tan of 1 over 2. All right? All right. So only other place that you have questions is where? What you printed out. Hopefully it's not pre-calc. Again, you guys don't have to do it. You guys can just skip it. What questions do we have? Yes? 24? Wow. Way to start right from the right to the back. Determine the area of a circular enclosure and a square enclosure made with, gotcha. Okay, so I only have this much fencing. $19.30. Was it feet? Okay. So if I was to do a square, what would the size of the square be? This is not just to her because she asked the question. It's for everybody.
Each side would be 482.5.
And how did you get that?
1930 divided by 4.
Since the sides of the square are the same, what'd you get again?
482.5.
Okay. So you're telling me that this side would be that and this side would be that. So what would be the area of this square? Now say it slower.
232,806.25 yards.
Squared. That answer is not on here. Oh, wait a minute. Yes, it is. Never mind. I was looking at the circular for the answer. Since it's not circular, it doesn't work. Yes? Not the surface area, just the area. Just the area. The only reason why we would use a surface area is if it was like a 3D shape. Okay? So if this was a cube, then yes. All right? Okay. So what if we did the same thing, but for a circle? So what would so if I have 1,930 yards of fencing and made a circle, what does that cover on the circle? The circumference. And the way I know the circumference, that is going to be 2 pi r. Is that right? So that means 1930 is equal to 2 pi times r. Yes? That means the radius is going to be 1930 divided by 2 pi. And the area of a circle is equal to pi r squared. And this is the reason why I chose 2 pi r rather than pi d. Does that make sense? So that means my area will be pi times this squared. So what is that calculation going to be? 296,000 or 202,000? Because you just cut me down to 2 choices, right? Either B or C. C? So here's the reason why I like using Desmos, just so you guys know. Apparently, Desmos doesn't like me using it. It doesn't matter if I use graphing or scientific. I don't see how graphing is going to help you guys anyways. So it was pi times, parentheses, make a fraction by dividing. And the top was what? 1930. Is that right? And it's over 2 pi. And then I have to square it. Look at that! by golly gee, he's there. And if you look at it, doesn't, oh, wait a minute. See this wrench on the, over here, the wrench? If you hit the wrench and chose the big capital A, it makes it more bigger. Yes, I said more bigger. And what I typed in is exactly what I wrote down, isn't it? So it looks the same, right? Unlike your Apple calculator. Next question. So 25 wasn't a problem? Well, we're at the end, so must be, we're good to go then. Any other questions on the review? And some of you guys like, I'm just opening up the review now. I certainly hope not. Some of you guys like, don't make eye contact, don't make eye contact. I didn't open up the review. Don't make eye contact, oh no. Yes?
So I was doing the Pearson this morning, and it went over like I think trig, like the tank and sig and all that. Is that gonna be on the test? It went over with it was like one of the last assignments on this week. It went over like sig and calls and all that.
I'm going to say this. If it's not on the review, it's not going to be on the exam. Number one. Was it in the A or the B? $17. Okay.
It was B, problem solving with geometry 2. That's where I saw it.
Oh, it does say that. Interesting. And that's starting on number 9. 9 to 14. Okay. Let me do number 17 really quick. That should just equal to 1/2 base times height. So chat. Because 17 looks like this. It tells you that the height is 40 and this base is 20.5. So it should just be Is that okay? Any other questions? Nothing? Well, let me give you this, this part so that you guys can actually do number 9 to 14 on your Pearson. Of course, I'm not the one that created these homework assignments, but I'm still going to do it. So, as it was mentioned about the 1 and 2, how you find the angle, right? So let's talk about those. So let's talk about trig ratios. So trig ratios, there's sine, there's cosine, and there's tangent. And the trig ratios only work on right triangles. So how do I want to do this? I got it. So let's focus on angle A here. So if I was to look for sine of A, the sine is always going to be the opposite over the hypotenuse. So the opposite would be opposite of that angle. Over the hypotenuse. So if we look at the hypotenuse always being the same, it'd be A over C. The cosine of A, that is going to be equal to adjacent over hypotenuse. Adjacent is what the side that's attached to it that's not the hypotenuse. So that's the adjacent. So in this case it would be B over C. And then the last one is called tangent. That's going to be your opposite over your adjacent. So again, this is your opposite. Your adjacent is the side that's attached that is not your hypotenuse. So it would be A over B. Does that make sense? So let's say, for example, they give you this. and they want to find x. So here's what I would tell you to do. Here's my angle. What sides are given? This is the opposite. And what is this part? Adjacent. So opposite and adjacent is which trig? Tangent. So I'm going to take the tangent of 29 degrees, and that's going to equal to, see ya, have a good weekend, is going to equal to 15 over x. I can make anything a fraction by putting it over 1. Now I can cross multiply. So x times the tangent of 29 degrees is equal to 15 times 1. So x is going to equal to 15 divided by the tangent of 29 degrees, which on your calculator, if I can remember, is 15 divided by, so the tangent is going to come from your functions. So you look at func, tangent of, what was it, 29? And now, be careful here, guys. Do you see on the calculator where it says DEG? You want to leave it in degrees. You guys aren't ready for radians yet, because if I click on this, if it's in radians, it's going to give me a different answer. So make sure it's in degrees. Got it? All right, so there it is. Now, notice that when I hit function, what else shows up? What's underneath sine, cosine, and tangent? Sine to the -1, cosine to the -1, tangent to the -1, right? What are those? Think of it as the opposite operation. To undo a tangent. Okay? So let's say is this find angle A. So again, here's my angle A. What am I provided with? What is this? What is this? So which trig function am I going to use? So in this case, I'm looking for A, right? So I want you guys to think of it this way. Opposite operation of this is, so if I'm going to do it to one side, I got to do it to? My memory is awesome, 37 over 57. It's going to be around 40.5 degrees. Are we okay? Yes.
Yeah, Apple calculator is very
Opposite, like sin -1 and the -1s, those are defined angles, and then the regular ones are defined sides? Or does it just depends?
Okay, so the inverse sine, or or what do they call it? They call it the inverse sine, right? So the inverse sine is to find angles. Yes. The sine, or the other sine, cosine, tangent, is to find your sides, because the angle is given. So if you look at any of these trig functions here, right, these are your angles. So you only have one angle involved with two sides. So always one angle, two sides. So now you could do that 1 in 2 pitch and find the angle that way. And what was your other question?
Oh, I was gonna say I was doing the homework and I got the concept. I just was struggling with
The Apple computer. I mean, the Apple calculator.
yeah, because it wasn't using degrees. It was using
Radians. The Desmos is going to default in degrees, right? So people who are taking actual trig has to be careful, because they need to know if they're operating in radians or degrees. And the radian looks different than degrees, by the way. Okay, so it's pretty obvious when people are operating in radians, because you won't see the degree mark. Okay. Any other questions? So that will help you from 7 to 14. And since it's not on the review, guess what? It's not on the exam. Any other questions? Yes?
Is this good for the exam? Whiteboard?
Why, you're taking it online? You're taking it here, you don't need one. I give you scrap paper.
Oh, okay.
Yeah. Hey, just so you guys know, to remember the sine, cosine, tangent, right? Some of you guys have heard of SOHCAHTOA, right? You're like, what the? So SOHCAHTOA is going this way. SOHCAHTOA, right? And some people have actually used these letters as a saying. So like some old hippie called another hippie token on acid, right? So however you guys want to remember it, that's certainly fine, right? But the more you practice it, the easier it becomes. Okie doke. All right, ladies and gentlemen. I want to see you next Wednesday for the exam, because Monday we have off. Is that correct? Because that's Memorial Day. So please have a wonderful, blessed, long weekend. Please be safe. Love you guys. See you guys next Wednesday.
Have a good weekend.
You too.